Hello, welcome to my channel. In this video, I'll be talking about measurements and units, which is an important topic in JAMB UTME syllabus. I'll start with the introduction. What is measurement? It's actually a process of determining the size, length, amount, or degree of something using a standard unit. And it is basic, it is fundamental to scientific inquiry. Every phenomenon in science needs measurements to be tested, compared, and subjected to experiment. And the product of every experiment is based on measurements. So measurements is an important phenomenon in sciences, including physical sciences. And measurements is just number. You can imagine if I just write 20. If I just write 20, you ask me, what do I mean? Yes. In sciences, measurements are just numbers. For it to be meaningful, you need to add units to it. And when you add units to a measurement, it becomes specific. Okay? If I write 20 meters now, it's making sense, right? Or if I write 10 degrees Celsius, it's making sense, right? So that is how important units is in physics. And like I said, physics physics relies a lot on precise measurements, and without consistent units and measurement systems, scientific progress will be practically impossible. Physical quantities are measurable properties of matter and energy. And physical quantities are broadly classified into fundamental quantities and derived quantities. What are fundamental quantities? Fundamental quantities are the basic building blocks of measurements, and they cannot be derived from any other quantities. Length is a fundamental quantities, mass is a fundamental quantities, and the rest that is listed below. Okay, it's very important for you to know all these fundamental quantities because you can be asked in exam, and it can come in the form of which of the following is a fundamental quantities. So take note of all these quantities. On the other hand, derived quantities are usually obtained by combining fundamental quantities through mathematical relationship, and the example is given below. Okay, speed is an example, and it's gotten from distance and time. Force is an example of derived quantities, and it is gotten from mass and acceleration. Energy is gotten from force and distance. Okay. Now, there are various types of measurements. For example, if you say length, some people may say meter, some people may say kilometer, some people may say miles. Okay, nautical miles. All these things are measurements of length. Okay. However, it's very important for scientists to understand each other when they are talking about measurements. And the way to solve the problems of misunderstanding among scientists throughout the world is to come up with international system of units, which is called SI units. Why is this important? You can imagine if someone come from China and I want to tell him about money and I say 20 naira. and the Chinese say maybe 20 yen, which is the unit of money, you will see that it will be difficult for us to understand each other. Therefore, we need to come up with a system that will make us to understand each other better. And that is why dollar is used throughout the world as a means of transaction for all of us to understand each other. If I say $20 and someone from Russia say $20, we will understand each other better because I know what $20 worth in my local currency, and so also a Russian knows how what dollar worth in his or her local currency. Okay. So the same way standard international units functions, it makes scientists to understand each other throughout the world. So this ensure uniformity and standardization in scientific communication. Okay. Now, what are the standard international units that is available? We have the base standard international units, which are listed below. We see length is measured in meter, mass is measured in kilogram, time is in seconds. So these are standard international units, meaning that anytime you measure, this is the unit that you should express your measurement because it is the standard international unit. There are other derived standard international units, for example, force, which is measured in Newton, pressure in Pascal, and energy in Joule. Okay, power is in watts, and electric charge is in coulomb. These are the derived standard international units. Okay, now one of the instruments that usually come out in JAMB is Venier caliper, and this is the diagram of a Venier caliper. Usually, they will not likely ask you to identify the parts. What they usually come up with is for you to read from the Venier caliper, and that's what we'll do. You can master the body parts, but it's not really very important as reading from the instrument itself. And that's the next thing we'll talk about. How do you read from a Venier caliper? Okay. You see, Venier caliper is made up of two scales, right? This is the main scale, and this is the Venier scale. Okay. If you want to measure with a Venier caliper, it's actually used to measure the diameter of a spherical object. And the spherical object is usually kept here at the jaws. The Venier scale is usually adjusted to grip the spherical object you want to measure. Okay. And after that, you take a reading from both the main scale, this is the main scale here, okay, and this is the vernier scale, okay. I'll show you how it is read, how the measurement is read, okay, in the next slide. Now, this is the main scale, and this is the vernier scale. You can see the marking of the main scale. Different people have different ways of reading it, but the principle is the same. To make it simple for you, to make it easier for you, I will read this in centimeter. Okay. If you look at the measurements from where I adapted it from, is read in millimeter. But this can require some calculation, which I will want you to avoid. Therefore, I will show you how to read it directly without doing much calculation. Okay. First of all, take note of the main scale. This is each of this marking is 0.1, 0.2, 0.36, 0.4, 0.5, 0.6789, 1.0. Okay, centimeter. This is 2, this is 3. So what you do is this. You look at the main scale and look at the last marking before the vernier scale starts. This is where the vernier scale starts from. You can see 0 here, right? You look at the last marking on the main scale before the vernier scale starts and you take the reading. Looking at this is 2.0, this is 2.1. So 2.1. Okay? Having read the main scale, the next thing is to read the vernier scale. How do you read the vernier scale? You look at where this vernier scale coincides with a marking on the main scale, and if you look at it, it is here, right? Good. Now, let's orient ourselves with the marking on the vernier scale. This is 1, 2, 3, 4, 5, right? Good. Now, you count from 0 to where the marking coincides and you write the figure here. This is 1, 2, 3. That is 3 here, centimeter. You can see that this is also equals to 21.3 millimeter. Okay, because you multiply it by 10 to convert it to millimeter. Okay, good. Let's look at the next reading. Like I said, you look at the main scale first, and in the main scale, you look at the marking just before the vernier scale starts. And if you look at this place, that is 2.0, right? Good. Now, the next thing is to read from the vernier scale. And before you do that, you need to look at where the vernier marking coincide with the main scale marking. And if you look at it, it is here. Good. Now, you need to orient yourself with the scale there. Look at this place. This is not like this. So, how do you read this? You need to orient yourself with the scale here. You can see that this is 0, this is 2, meaning that this one will be 1, this will be 3, right? Etc. This will be 5, and this will be 7, right? So, this is 0.5, 1.5, right? So, this is 1.5, which will be 1 5 because you can't put point here. Centimeter, which is equivalent to 20.15 millimeter, because this is in centimeter. To convert it to uh, millimeter, you multiply by 10, right? Good. So I'll leave the last one for you to read. Okay. This is micrometer screw gauge, and it is used to measure the thickness of an object. Okay. You can see it has two scales, sleeve scales and the thimble scale. And this is what we'll be looking at in the next slide. And take note of this is called the index line. You can see this is the index line. This is the sleeve scale and this is the thimble scale. I'll read both of them in millimeter. Okay. Now, what you first do is you look at this the sleeve scale. This is 5, 6, 7, 8, 9, 10, 11, 12. Okay. And if you look at the markings below, it's they are point five point five. So this is 0.51, 0.52, 0.53, etc. Look at this, this is 11.5, 12.5. Okay, that is 12.5. Okay, millimeter. You settled the sleeve scale. Now to the thimble scale. For you to know what to read on the thimble scale, you need to see where the index line coincides with the marking on the thimble scale. And if you look at it, it is here, right? Good. And if you look at the marking here, this is 11, 12, 13, 14, 15. So this is 16. Okay. Now, whatever you get here, 16, you multiply it by 0.01. Okay. If you multiply it by 0.01, it becomes what? 0.0.16, right? Now, the next thing is to add it to this 0.16 millimeter. Then it will give you 12.66 millimeter. So this is the reading on this one. Now let's go to the next one. This one is 15. I'll be a little bit faster now. This one is 15 point. This is 15. This is 16, right? 16 marking. Good. We got it now. 16.0. Okay. Then let's look at the thimble scale. If you look at it here, you see this is 34, 35. It fell in the middle between 35 and 36. So this is 35.5. Okay. So that's 35.5 multiplied by 0.01, which is equals to what? 0.355. So when you add it here, 0.355, what will it give you? That will be equals to what? 16.355 millimeter. So this is the reading on this scale. I'll leave the next one for you to answer. This will be 67.5 plus 0.26. I think you should be able to get that. Okay. Now, the next topic we'll talk about is dimensional analysis. And dimensional analysis helps verify physical equations and convert units. And its main role is to check the consistency of equations. You know, sometimes when you are given a formula in physics, and if you know the units of that quantity whose formula you are given, you can tell whether that formula is correct or not. So what make you to know is dimensional analysis. You probably have been doing it, but you don't really know. Okay. So that's what dimensional analysis do. Okay. And in dimensional analysis, every physical quantity has its symbol. It has its letter that is used to represent it. Okay. And this is what is displayed here. Okay. The length, the mass, the time, and etc. Okay. Now let's do example of dimensional analysis. You know, force is equals to mass times acceleration, right? Mass in dimensional analysis, mass is represented by capital M, and you can take note of this square brackets. Okay, it helps you in uh, getting yourself oriented to the expression. Okay, that is mass. And acceleration, we know it to be either the velocity. Acceleration is actually velocity over time. And we know velocity is what? Distance over time. all right? Distance over time, okay? And distance is represented by L over T over T. This is equals to what? L over T squared. And this is equals to what? L T raised to power minus 2. Okay? This is acceleration, right? Good. So this will be L, okay, times T raised to power minus 2. You can see that this is dimensional expression of force. You can see how we derived it. Let's look at energy. Energy is known to be force times distance, right? Energy is force times distance, right? Now, we know force to be this, right? So it will mean that we just multiply let's represent force here, which is equals to M L T raised to power minus 2, okay, times distance, which is also L, which is the letter that is used to represent it in dimensional analysis. So this will be equals to M L squared T raised to power minus 2. So that's how we got this. Okay. So if you're able to do dimensional analysis of a physical quantity, you'll be able to tell whether the uh, formula to calculate it is correct or not. And you also be able to tell from the units. Okay. So take note. You can see a similar question in the exam. Now let's go through some questions. What is the standard international unit of length? We know all these are correct. As units, they can be units. They can be units. This one too can be units, and this one too can be units. But the standard international unit is meters. Okay. Which of the following instrument is used for measuring the diameter of a small spherical object? Measuring tape, no. Vernier caliper, yes. Stopwatch, no. Micrometer screw gauge is used to measure the thickness of an object, okay, of a small object. So the correct answer is B. How many divisions on the vernier scale are typically found in a standard vernier caliper? Standard vernier caliper usually have 20. Okay, this is an example of a standard vernier caliper. Okay, usually have 20. Right. I think I'll leave the remaining question for you to answer. Go through it as I'm scrolling. Pause if it is too fast, and try to write your answer in the comment section below. Okay. Please don't forget to like, subscribe to my channel, and share with your friends for them to benefit from it too. Thank you very much for listening. Bye bye.